as the name implies, we provide drinking water and sanitary sewer services for residents of the city of Evansville. Our water services also, we sell to some wholesale customers who sell to basically the rest of Vanderburgh County. So if you don't have a well and you drink water, it probably came from us if you're in Vanderburgh. Yeah, we've been working for a number of years on replacing a water treatment plant that's over 125 years old. That's down on the river, obviously. We take water from the river there and we treat it to drinking water standards. That plant is actually in two pieces. There's the older part and the newer part. Well, the new part was built in the 1970s, but it's still in really fine shape. So we were originally looking at replacing the entire facility and building another facility down next to Waterworks Road there. That turned out to be far more costly than we could afford under our rate structure. So we started looking at building a sort of a hybrid, reusing part of the old plant and replacing the older part of the old plant. And then we started looking at some previous groundwater studies and came up with the idea of renovating the newer portion of the existing plant and then blending in treated groundwater to mix with the water from the river. And it turns out that that appears to be quite a lot less expensive than the previous proposals. The so-called hybrid surface water approach, which was keeping part of the old plant and replacing the other part, looked like it was going to come in the $250 million range. The groundwater solution, if we take the new groundwater plant and renovate the newer portion of the old plant, that looks like it's going to come in the $150 or so million range. So in round numbers, we hope we could save capital costs up to $100 million perhaps. Part of what started us looking this way is that there's a group of contaminants that are pretty newly regulated called PFAS, PFAS, that stands for per and polyfluoroalkyl substances. Those are the so-called forever chemicals. Some of them are carcinogens, and they're basically everywhere. They're part of making nonstick cookware and fire foams and you know, those cardboard boxes from the restaurant with the coating inside so stuff doesn't stick. Yeah, that stuff too. So PFAS is basically everywhere. And a couple of those species, chemical species, are present in the water from the river. Of course, there's a lot of industry and a lot of people living upstream of Evansville. So we have concentrations there that may put us in the situation where we'll have to build future treatment for PFAS in the not too distant future. So we were looking at possibly building this new plant for $250 million and then coming back a couple of years later and building another 9-figure project perhaps to treat for PFAS, and then that adds operating costs too. So when we started looking at groundwater, the question was, is there PFAS in the groundwater here? We have really nice aquifers here, just like most floodplain communities along the Ohio River have similar geologic settings. And it turns out when we tested it, there was very little, if any, PFAS that showed up. We built a well, tested it for 72 hours, and we had non-detect for all the measured species of PFAS chemicals. So that looks pretty promising. So blending, you know, a 50-50 blend of the river water with the water from the aquifer looks like a nice alternative to building new treatment facilities. In a lot of places, we actually, communities pump groundwater because of droughts and floods, that it's a more consistent supply of water, that you're going to get similar water quality all year round. Water levels in the aquifer will rise when the river comes up, and they will decline when the river level goes down, but it doesn't have the same effects on water quality that you would have in the river. If you're pumping straight out of the river, you're getting what's there today. When you pump from an aquifer, you're getting rainfall that may have recharged 20 or 50 or 100 years ago and mixed in with water that may have come from the river and from other surface waters. So it's a different kind of animal. Groundwater tends to average everything out over time, a lot more than taking straight from a river. We have a contractor, an engineering contractor under contract right now who's working on the design of a groundwater plant. Part of that project will also be doing the site assessment and determining where we want to put the well field and where we want to put the plant. Because our intention is to treat river water and treat groundwater and then blend it after it's treated, we'd like to have the treatment plants close by one another. So chances are the groundwater plant will be located also on Waterworks Road right near the existing plant. There's a number of advantages, but one of them is that it reduces the amount of changes that we need to make to our distribution system. We would still be injecting at the same injection point that we are now. Now, a lot of communities that are predominantly groundwater communities will have multiple well fields, and they will inject at various places in the distribution system. In order to do that, we would have to make changes to our distribution system that we're not ready to do yet at this point, where our intention is to work with this blended approach. So it's convenient to do it in one location so that all our customers get the same water quality. We don't want to be in a situation where, for example, half of our system is groundwater and the other half is treated river water. In that case, some of our customers would be getting the relatively lower PFAS groundwater, and others would be getting the relatively higher PFAS river water, and then we'd have to treat that. So it's better for us to try to blend at one location. So chances are the well field and the treatment plant will be really close to the existing plant. There are a number of other benefits to using the groundwater blending approach. One of them is that groundwater is basically the same temperature all year round, which will reduce the amount of temperature variability in our distribution system. One of the things we do experience is a lot of additional main breaks in the winter when the water's cold. This is a pretty common thing. So we're hopeful that that mixing groundwater may help a little bit with main breaks in the wintertime. It'll also lead, in all likelihood, to lower concentrations of things like distribution byproducts and so forth. One other aspect of our plan is that when we treat the groundwater, we understand that the water quality won't be the same as river water. The biggest difference is it will have more hardness. We are planning to treat the hardness to basically maintain very similar water quality to what we have right now. So I know there are people who've said groundwater's hard and we don't want hard water. Well, we'll work on that, and it's all part of our plan to make this be as similar as it's been as we possibly can going forward. One of the things that this whole exercise of working on looking at a groundwater system or augmenting with a groundwater system here in Evansville is it's really important to know that groundwater, surface water, drinking water, sewer water, storm water, there's really only one water. It shows up in different places. It has different characteristics in terms of what contaminants are there, what suspended solids are there, how much erosion is happening, all of those kinds of things. So we're trying to think holistically here at the utility to make sure that we're not missing opportunities to have our different functions, our water side and our sanitary sewer side, to make things as cooperative as possible and to treat this as one utility, not two. And in some cases that may be just as simple as looking at a parcel of ground and deciding, should I put water infrastructure here or should I put sewer infrastructure here? And what will be the implications of that for the other utility as we go forward? So we really are trying to pay attention to the fact that we provide both these services, and it's necessary for us to be thinking about the whole system in the long run rather than thinking it is two separate things. Well, our bills right now are set up based on a rate case that was done 5 or 6 years ago, before my time. That rate case had a number of step increases, and we've been going through those steps. This project will not affect any of the existing rate case. What it can do, though, is if we're successful in saving a lot of money, what it will do is it will either delay or the next rate case or make it smaller. So it will be, rather than having to take on building a PFAS treatment facility or building a whole water treatment plant, it would be mostly dedicated to distribution system improvements and things like that. And we do see those coming down the road, but certainly not in the next couple of years while we're building a water plant. The project to repair the sinkhole at Riverside and Chestnut is continuing. It appears that we're going to be able to add sewer lining to the Chestnut Street sewer, which will be much cheaper and less intrusive than replacing it, which is great. The portion of the sewer that's right there at Chestnut and Riverside where the major failure happened, that's fully excavated. All the sheeting is in place to make sure the hole doesn't collapse. We expect to be laying pipe there soon, and we need to replace that piping and put in a manhole, and then we're going to be relocating a diversion structure that used to be in the southbound lanes. We're going to relocate that out of the traffic lanes to make it a little easier for us to work on. And we do expect to be on target for getting some traffic lanes open around the end of October, plus or minus. There will be more things to do, but we will start getting the traffic lanes open as soon as we can. If you're wanting to reduce your water bill and conserve water, the best tools we can provide to you are at ewsu.com/mywater. We also have the MyWater app for either Apple or Android phones, and it can send alerts that let you know that you're using too much water. You can configure how all that goes, but you can monitor that way. If you do that, you can closely monitor how much water you're using every day. You can set up alerts. So mine, for example, I just bought a house, and I've set the alerts to let me know if I use 100 gallons of water in a day. So the other day when we filled up the hot tub that came with the house, I got an alert. So I know it works. But those kinds of things will help you know that you're leaking water somewhere. It could be you have a faucet left open in the yard or a toilet that's running or something like that. So you take advantage of those tools and monitor your use, because it doesn't take too much of a running toilet to cost you a lot of money. And the other thing to remember is if you're a residential customer, your sewer bill is calculated based on your water usage. So when you save on water, you also save on sewer. It'll also tell you about things like boil water advisories, and it will tell you, you can also pay your bill through there. So it's really a one-stop shopping for customer service with EWSU.